Good morning, dear students. Hope you are doing good and listening well all the classes continuously. Here in this filtration, we are trying to remove the leftover impurities from the previous treatment stages in the name of sedimentation and sedimentation with coagulation. In this particular step, we have seen what is happening and what are the mechanisms we may observe. We were discussed in detail during the previous session. That means in the last session, we will discuss the basic stages of treatment. Stages in the sense here, in this particular context, what are all the different steps we may observe in this filtration, we will discuss. Now we are entering into the first type of filtration, that is slow sand filter, followed by the other one is rapid sand filters. By the time now you may be observed and you may get an idea, or else you may have an idea, that is the filtering media in treatment works is nothing but sand. Of course, even the gravel and the small pebbles also acts as a filtering media. Why? Because we were discussed in the previous session about those voids and how they may be clogged, how they may be blocked. We were observed. And what is the sedimentation which we may observe in the filtration, we were discussed in detail in the previous session itself. Bacteriolytic action also we have seen, because the bacteria will be attracted by the blocked water within the voids, which gives the information on changing of sand bed. Similarly, the electrolytic action of water also we have seen. As the water is continuously passing through the voids, the surface of the voids lost the electrolytic action, which gives the information about the washing of bed is mandate. See here, there are two types of filtering media in this treatment of water. And the first one is slow sand filter. Slow sand filter. In sedimentation, we were removed all the settled particles. In sedimentation with coagulation, we were removed all fine colloidal particles. In this step, we are trying to remove the bacteria, algae, and any other impurities which may cause bad odor. And of course, some other unwanted impurities if they are existed at. Their limits which were not permissible. Right? Now we'll start these slow sand filters. The whole process can be divided into two major categories, or else the working process of slow sand filters can be explained in two steps. The first one is construction of slow sand filter. How we can construct, how we will make this bed, filter bed, that we'll see. Most generally, or else most of the cases, The slow sand beds may construct in the area of 100 to 1000 meters with an average depth of 2.5 meters to 4 meters. Okay, the top of the bed is filled up with sand in the size of 60 to 90 centimeters, which is supported on 30 to 60 centimeters thick gravel bed. So most generally, they used to construct in the area of 100 to 1000 square meters with an average of 2.5 meters to 4 meters, and the bed is filled up with sand in the size 60 to 90 centimeters, which is supported on 30 to 60 centimeters thick gravel bed. See here, it is the coarse sand, of course, gravel or coarse sand followed by pebbles. The top sand layer is supported on gravel bed. Understand? The most effective size of filter media is generally 3 to 4 layers of gravel having thickness of 15 to 20 centimeters of each. And the coarse gravel is placed in the bottom, whereas the small size gravel is placed in the top layer. One more time. The sand bed is placed on the top with a thickness of 60 to 90 centimeters, which is rest on 30 to 60 centimeter thick gravel bed. Normally, 3 to 4 layers of bed will be constructed with 15 to 20 centimeters of each if we go for gravel. See here, this is inlet. Which is inlet here? This is inlet. Through this inlet, water enters into the filter, which has the filter media made up by slow sand followed by coarse sand, which is rest on the pebbles. The entire setup is laid on concrete. See a supported concrete layer which is sloping towards the central longitudinal drain connected by open jointed system under the drain. One more time. See here. The top layer is fine sand, followed by coarse sand, and then pebbles, small size of filter particle materials, pebbles. Here in this context, see here the bottom gravel layer is 40 to 60 mm with an intermediate layer of 20 to 40 mm size, and the top layer is filled up with 3 to 6 mm gravel. The bed is supported on concrete layer, which is slope towards the center. Just remember the settling zone structure in sedimentation. As the water enters to the central part due to the sloping bottom, and from there water will be sent out. See here, next the water from the sedimentation tanks enters slow sand filters through a submersible inlet as shown in the figure. The water distributed uniformly. The water will be distributed uniformly, and through this step, water enters into the next chamber, and the difference between the water level in the inlet in this chamber and water level in the outlet chamber, it gives the information of loss of head. When this loss of head is increasing, that means the filtered water is reducing. If the loss of head distance is increasing, from here to here loss of head. If the size is increasing, what it means? The filtered water ratio is decreasing. Unless when the amount of water, filtered water is reducing, obviously the gap will be increased, which gives the information of clogging of sand media. At that time, the sand bed has to be removed and it should be washed out. Understand? One more time. See here, through this inlet, water enters into the inlet chamber. As the filter media, this is filter media, complete filter media. Water is entering, where the water will be distributed uniformly on the sand bed, which is made up within a 15 to 20 mm layers. The top layer is fine sand, followed by coarse sand, pebbles, else large gravel particles, small and ultra and else fine gravel particles, through which water enters. Understand? As the water is filtering through these beds, the filtered water entering into the outlet chamber. Here is a float with a telescoping pipe. Through this float, water enters into the outlet tube and will be supplied for the requirements. The difference between the level of water in the inlet and level of water in the outlet chamber gives the information about the loss of head. That means the level of the untreated water and level of the treated water in the outlet chamber, that both the difference gives the information of loss of head. If the loss of head is increasing, if it is increasing, that means the water is the quantity of water that is being sent to the outlet chamber from this inlet chamber is reducing. Once the water quantity is reducing, it means the water is not passing freely through these beds due to the blockage of sand voids. In that particular time, the bed has to be removed and should be washed out. See here, the water distributed uniformly over the sand bed without causing any disturbance and passing through the filter media of sand with an average of 100 to 200 liters per meter square per hour. That is the efficiency of slow sand filters. The process of filtration is continued till the variation between the level of water on filter media and the water level in the outlet chamber. See here, level of water on the filter media and level of water in the outlet chamber is slightly lesser than the water level on the sand. The difference of water level between the water on the sand bed and the water level in the outlet chamber is called as loss of head. When the loss of lead is increasing, it means blockage of sand is happened, that has to be removed. How much we must remove? Simply 2 to 3 centimeters. Here, the 2 to 3 centimeters of sand in the filter media, 2 to 3 centimeters of top sand media has to be removed by scrappers and should be washed out, then will be replaced with washed sand again on the top of the filter media. Understand? Simply one more time. See here, the water enters through the inlet and will be distributed on the filter media. And through this filter media, water will be sent to the outlet chamber. See here, the water level on the sand bed and the water level on in the outlet chamber both combinedly gives the information of loss of head. What is loss of head here? The difference between the water level on the sand bed and the difference and the outlet chamber is loss of head. The loss of head is when the loss of head is increasing, it gives the information about the blockage of sand as the water entry into the outlet chamber is reduced because the voids of the sand block and not allowing water into this side. In such situation, obviously the loss of it will be increased, which gives the information that sand has to be replaced. How much of sand? The top 2 to 3 centimeters of the sand bed has to be removed and should by using mechanical scrapers, and that should be cleaned, that should be washed, dried, and that has to be replaced, or else that must be placed after washing on the sand bed. Else we may be filled up after removing 2 to 3 centimeters of sand with new brand new sand after removing up top layer of 2 to 3 centimeters of sand. Either we can use after washing, else we can use brand new sand again on the top of the sand to continue the process. Understand? The efficiency of sand bed is 100 to 200 liters per meter square per hour. And here the gravel is acting. See here, the top layer is made up of fine sand, coarse sand, and pebbles. Pebble in the sense gravel. Else even in place of coarse, we may be used sometimes the gravel, fine gravel materials. But the structure is fine sand, gravel, coarse sand, pebbles. With an layers, with an arrangement of 3 to 4 layers having thickness of 15 to 20 centimeters of each. Understand? And next is efficiency of sand filters. The first one is bacterial load. By using this method, we can remove up to 98 to 99% of bacteria in this method. As the efficiency is not 100%, water further treatment is necessary before this water is being supplied to the public. Treatment in the sense disinfection is required because only 98 to 90% of bacteria is removing in this method. To remove complete bacteria, disinfection is required in this method. Color. Slow sand filters are not efficient to remove the color. Only 20 to 25% of color from the raw water can be removed by this method, and they can be efficient only up to the 50 ppm of turbidity. If the water turbidity is more than 50 ppm or is more than 60 ppm, further treatment is required before the water is supplied to the public. Understand? See here, this is about the diagrammatic view of slow sand filters. Understand? Slow sand filters, working process of slow sand filters can be explained in 2 steps. Construction. See here, construction, the top layer is sand made up of 60 to 90 centimeters, supported and 30 to 60 centimeters thick gravel bed. And most probably, or else in most of the cases, the gravel layer will be placed within a 15 to 20 centimeters of each, 3 to 4 layers, instead of the pebble layers, instead of top, in the place of bottom layers. And next one is normally the bottom gravel layer is made up of 40 to 60 mm, intermediate layer 20 to 40, the top layer is filled up with 3 to 6 mm. In the layers which is at pebbles zone, but the structure fine sand, coarse sand, gravel, or else pebbles. The gravel layer is made up of 40 to 60 mm with an intermediate layer of 20 to 40 mm. The top layer is filled up with 3 to 6 mm layer. The bed is supported on concrete layer which is sloping towards the central longitudinal drain connected by open jointed system under the drain. the filtered water enters into the outlet chamber, which has a float connected to a telescopic pipe. After filtration of water, it enters through the outlet and it goes out through the outlet. The difference between the water level on the sand bed and the water level on the float or else in the outlet chamber, it gives the information of loss of head. When the loss of head is increasing, which means the quantity of water that enters into the outlet chamber is reducing because of the because of the blockage of voids in the sand media, and it gives the information on changing of sand bed. We may not remove entire sand bed, changing in the sense only 2 to 3 centimeters of the top of the sand bed will be removed by using mechanical scrapers, and that should be dry, the wash and dried, and then it will be replaced in the place where we have taken. Else we may produce, or else we may add some amount of fresh sand to continue the process. And here only the efficiency is 100 to 200 liters per meter square per hour. And see here, I already told you that loss of head will be increases when the silver sand bed voids are blocked. See here, the efficiency of sand filters, second category, bacterial load, only 98 to 99% of bacteria can be removed by this method. That is the reason disinfection is needed before we are sending this particular water to the public. Even color is, the slow sand filters are less efficient to remove the color. Only 20 to 25% of color can be removed in this process. Even these are not efficient to remove the water when the turbidity of water is more than 60 ppm. Next one is rapid sand filters. Hope you understood about these slow sand filters. Construction of slow sand filters: fine sand, coarse sand, pebbles. The gravel layers, 3 to 4 layers. Fine sand, 3 to 4 centimeters. I mean, up to see here, after the process, 2 to 3 centimeters will be replaced, and with clean sand and continue the process. The removed sand can be reused after washing under water flows. Understand? If any doubts, please contact me, either message, mail, or phone call. Thank you.